Good day, students. Today we can discuss about Power BJT in the Electron Devices and Circuit Theory subject. So, what is Power BJT? This Power BJT is are bipolar devices with three terminals similar to a normal BJT, that is small signal BJT, collector, base, and emitter. In order to increase the on-state resistance and they decrease the on-state resistance and increase the off-state depletion rate, this power BJT structure is made somewhat different from your small signal BJTs. What is the major difference is in the structure is the doping level is highly increased compared to a normal BJTs. The PN layer of BJT are made in vertical structure, unlike the small signal BJT. That is, others are horizontal structure. These are made of vertical structure, and the collector terminal should be at the bottom of this structure compared to a normal BJT. So this, because of this vertical structure, what is the what is the advantage you are getting is it maximizes the cross-sectional area of the BJT regions. So the symbol of BJT, it is normal to your NPN and PNP transistor. That is no much more difference from your symbol. How should be the structure? So it is constructed with this like a four-layer structure. And in this four-layer structure, alternatively, N layer, P layer are doped. The vertical structure is preferred here as in the figure because it maximizes your cross-sectional area. Doping in the emitter layer is quite large. See this emitter layer, the doping is 10 power 19. It is very much larger compared to the this 10 power 19. And then the base doping is moderate, which is of 10 power 16 centimeter per minus 3. And the N minus region that forms the collector half of the collector base junction is usually termed the collector drift region. It is of 10 power 14. And the N plus region that terminates that drift region has a doping level similar to that found in the emitter. The doping level near to the collector is similar to the emitter 10 power 19, 10 power 19. Okay. So the N plus region that terminates, it is considered to be called as collector. Okay. To have good amplification capabilities, base thickness should be as small as possible. Micro meter to few tens of micrometer. Base region is made somewhat fewer in region. So this because the lightly doped collector refrigerant determines the breakdown voltage of the transistor, the power dissipation in the devices gets reduced. So there are two types of RBJT as we have seen the symbol NPN and PNP. So the NPN, see this N plus region, collector region is N. And here in this PNP BJT, PM emitter is P plus, base is N, and the collector is P. So PNP. Here the narrow N base and the collector side P layer is narrow and heavily doped. The two emitter with interleaved base structure allows the base and collector currents to flow through the two parallel paths, resulting in a low on-state collector emitter resistance. So both are having the similar structure. Only the thing is you are going to replace N by P and P by N. So how should be the characteristics? There are normally the characteristics is having our normal BJT has three regions. So here normally three regions, but the saturation region is splitted as two things. One is this saturation region is splitted as two, quasi-static region and hard saturation region based on the mode of operation. So see this. There are four regions: hard saturation, quasi saturation, then based on your doping, based on your biasing. Okay, so how it should be is if the region is base emitter junction is reverse biased and the base collector junction is reverse biased, it is in the cutoff region. Okay, and if the base emitter junction is forward biased and the base collector junction is reverse biased, the region is said to be active. This is your active region. Normally, what we are seeing in your normal BJT, and when it gets happened is because of this in the active region, increase in VCE, the IC increases slightly, and it will be operating as an amplifier in this active region. Okay. Then in the saturation region, if both the junctions are forward biased, there is base emitter and the base collector junction are forward biased, it will be acting as saturation region. But what is there? It is quasi-static region and hot saturation region. Quasi-static region that is not existing in your normal power signal, small signal BJT. So the region between hot saturation and active region is called as quasi-static region. As you can see in the diagram, it is in the center. When power BJT is to be used as a switch at high frequency, it is operated in quasi-static region. And if you are increasing your IB, that is your base current, more, power BJT gets driven into your hot saturation region. The resistance of the device is less than in quasi-static region and IC is almost constant in the hot saturation region. And while seeing the characteristics, you have two breakdowns. One is primary breakdown, another one is secondary breakdown. So what that takes place because of the avalanche breakdown, normally the primary breakdown. But secondary breakdown at large collector current, the collector emitter voltage drops. That is VCE gets dropped. In this region, the temperature increases rapidly and the power BJT gets damaged. So in order to prevent that, you should be highly focusing on the current, that is the collector emitter voltage drops at large collector currents. So the second breakdown occurs due to the negative temperature coefficient region, and if you are increasing that, the voltage drop across the drift layer starts decreasing and this voltage starts increasing. This process continues, consumes a large power dissipation and finally damage. So secondary breakdown you should avoid and you should carefully. So it should be operated in a safe operating area. So focus on the curve between the stable and the unstable should be very much taken into account. So these are the four modes which I have told you. When it happens, it is when it is operating as cutoff mode, active mode, and quasi saturation mode, and the hot saturation mode. So what are the advantages of using this power BJT is have small turn on and turn off times, and it will be acting as a binormal bipolar device. High switching frequencies are there and low cost, small on state losses. The disadvantage is driver circuit is complex because you have to prevent from the primary breakdown and the secondary breakdown. Storage change in base increase switching time. So it is actually deployed as a 10 power 16, but if you are changing some base with degree, it increases your switching time. Major application is switched mode power supply. Apart from that, it is used in inverters, that is DC to AC inverters. And some high power AC circuit analysis, power factor analysis, this particular power BJT is used. So hope you have understand the power BJT. It is one of the special semiconductor device which we have discussed. And because of this, only the reason for the using this is to make your device to be turn on resistance. Thank you.